At layer 2, we have the field for MAC addresses. So our MAC address header, at least on the Ethernet side, has the MAC address inside. Again, down the WAN link, you won't necessarily have a MAC address in there. Again, it could be the PPP header or the ACLC header. But on our Ethernet segment, we have to have that MAC address header in there, which has our MAC address, which is the unique identifier that goes along with our PC. Let's take a look at the MAC addresses. So the MAC address on your PC, again, PC, router, switch, camera, thermostat, light bulb. If you're talking anything by IP on an Ethernet or on like your home network, it is going to have a MAC address. So again, it's not just a PC, clearly. When we look at the MAC address, it's a 48-bit field. So again, we call this the burned-in. MAC is Media Access Control. It's a burned-in address, so it means it's a read-only component. It's built onto all network interface cards and network interface devices that has communication. We have these 48 bits. Now, they can be what we call locally assigned, so we can change them. We can in software define what we want the MAC address to be, but we typically just call it the burned-in. We would typically just use that locally assigned, not locally assigned, burned-in MAC address on your machine. So if I look at it, for example, 00000C, that's each one of these digits represents 4 bits. It's a nibble. So 4 and 48, so each one of these represents 8 bits or a byte. So this is the first 24 bits here, and that's what we call the OUI portion of the MAC address. OUI is organizationally unique identifier. OUI. The OUI, again, most of the time we call that the manufacturer ID because it dictates which vendor actually was assigned that. So the IEEE assigned 00000C to Cisco, for example. So all the original Cisco routers and still Cisco devices today will have this as the first 3 bytes of their identifier. The second 3 bytes of the identifier, 01A562, and I just made these numbers up. This is, I don't know if you want to call it a serial number, but it's the unique portion that goes along with the device. So that whole 48-bit field in here actually represents the MAC address of a device. And this we would know as a Cisco device because of the OUI field here. There are different types of MAC address put in place. We have unicast MAC addressing, which is what this is. It's a unicast. It only belongs to one device. We have what's also known as a broadcast, whoops, B-R-O-A-D, broadcast, put an R in there as well, cast, which is all Fs, FF, FF, FF. Again, this is a MAC address that goes to everyone. So there's the broadcast MAC address. There's also what's called a multicast MAC. So in our overall communication scheme, we have unicast, broadcasting, and multicasting at IP as well as at MAC. So there are unicast IP addresses, there are broadcast IP addresses, and there are multicast IP addresses as well. At layer 2, it's just our multicast MAC address. So 01005E is the well-known OUI for multicasting with another identifier that typically relates back to the IP address field out here, 000001. I guess this is not a valid number out here. I mean, it could be, I suppose, but again, I just had to put something out here. But again, just to show you the OUI that's associated with multicasting, so it is specific. So when your NIC, your network interface card, is listening for traffic that it wants to process, what's it listening for? It's listening for its MAC address. So in the case of this Cisco router, 00000C, 01 AS, it can't be AS, it's MAC, it's hexadecimal A562. So if the router hears that MAC address right there, as long as it's associated with that router, it will process it. If it hears this broadcast address, it will process that and look at the other layers, at the other headers behind it. If the router is set up to listen for multicasts and it sees this, it will look at the rest of the number out here, and maybe, for example, your you're a RIP router or an EIGRP router. Well, this will be the IP address essentially that's associated with you. So if you're running, say you're running RIP, let me change this to it's a little bit closer to a representation of RIP, where RIP's multicast IP address is 224.0.0.9. Its multicast MAC address is going to be 009 out here. Again, 224.0.0.9. Let's see. I think this is actually a fair representation of what that number is going to be. So again, the multicast MAC says it's a multicast. So if my router is listening for RIP version 2, it's going to listen for this OUI and this specific number. Go, yeah, that's mine. Let me hand that up to the routing process. And again, all RIP routers in my network listen for the same multicast MAC. So we don't have to send out unique packets to each router. We can send out one multicast MAC on that segment, and all routers will process it. Again, the whole purpose of doing multicasting is to make it more efficient on my network. When I multicast stream any data, it's one stream of information that more than one device is going to have to pick up. Again, unicast is one-to-one, broadcast is everybody, and multicast is a group of devices. Could be 1, could be 20, could be everybody. You can multicast to the entire infrastructure if you want to, which is why down the road, IPv6 actually combines these two together. So there really is no broadcasting anymore. IPv6 says, hey, if you could multicast to everyone, why would you want to broadcast? So we only use unicast and multicasting in IPv6. But again, we'll save that discussion for the IP section. One more little piece in here. There's several different ways that we can represent the MAC. I always use double colons. I always use colons, double dots, colons when I do this. You may actually see places where they'll use dashes, 0000-0C. They may actually put them in supergroups. So again, I should put the whole thing out here, 01A562. You may see Cisco's representation lots of times. They put them in 16-bit notation. So 0000 colon 0C01 colon A562. Also a valid representation for a MAC address. Again, it would be wise to be familiar with all of these, because depending on which documentation that you read, which router interface you're looking at, which white paper you're reading, you may go, oh, you're not supposed to use dashes, you have to use colons. Well, it completely depends on how you want to represent it. You have to remember that just like an IP address, it's, when we look at an IP address 192.168.1.100, that's not 4 octets. That's 32 bits worth of data. And when machines actually look at it, they look at the entire 32 bits. We look at a MAC address, we don't look at the dashes, we don't look at the colons, we look at the 48 bits that make up the MAC, and that's all we look at. The way that we represent it visually is really just for human consumption, the same thing that we do for IP addresses.